This is a continuation part of the biostatistics, where previously we were discussing about tests of significance. We have seen about the t-test, both paired and unpaired. Now this is the chi-square test. Chi-square test is an alternative method of testing the significance difference between two or more preparations. That means you can perform this test when you have any number of groups. There is no restriction saying that you must have only two groups, etc. You can perform this chi-square test when you have any number of groups, and it is an alternative method for testing the significance difference between two or more preparations, and it is given with this formula, where O is the observed frequency and E is the expected frequency. Now, how do you calculate this expected frequency? Expected frequency is calculated by row total multiplied with that of the column total, and this is divided by the total of the total. That is about the chi-square test. Now, next test is the Z test. Z test is generally performed whenever you have large samples, and this test helpful in testing the significant difference between two means. Now, t-test also was something which was used to test the significant difference between two means, but for the t-test the sample must be less than 30, but if it is greater than 30 then you perform the Z-test, and the criteria is again it can be random sample, but the data must be quantitative data and it must be normally distributed with the sample greater than 30, and this is given by this particular equation. Now Z-test and the t-test are almost similar. So here it is given by the standard error of means, difference in the standard error of means. Now the next one we have is the Z proportionality test. Now instead of means in that place, suppose we have proportions, then you go for the Z proportionality test, that is for significant difference between two proportions. This Z proportionality test is performed. So it is given by Z is equal to P1 minus P2 by standard error of P1 minus P2, where P1 is the proportion of the first sample and P2 is the proportion of the second sample, and SE P1 minus P2 means is the standard error of difference between the two proportions as seen in the before topic. Now the next thing is the correlation. So what is correlation? In previous all tests, whether it is t-test, chi-square test or Z-test, you are just calculating the comparison. You are comparing things, but in correlations what do? You see the relationship between the two things, or association between two quantitatively measured variables. So that is what exactly correlation does. For example, a relation between dental caries, dental fluorosis and fluoride concentration in water. This is the correlation part. Now what is correlation coefficient? So to tell the relationship or the association, you need a measure. So the measurement of the degree of relationship between two variables is known as the correlation coefficient. It indicates the direction as well as closeness of relationship between two variables. Now, if you want to give a relationship between two quantitatively measured variables, based on the correlation coefficient, you can tell how close the association is between the two variables. Now this correlation coefficient is generally denoted by the letter R, and the value for the correlation coefficient R, it lies between +1 and -1. Now let us see the various types of correlation that we can have. So you have a positive correlation. When do you say it is a positive correlation? When the R is +1. Then you have a negative correlation when R is -1. Now let us see the positive correlation, that is when R is +1. Here correlation is said to be positive, that is when they move in the same direction. It implies that when one variable increases or decreases, the other variable also increases or decreases. Okay, for example, carbohydrates and dental caries, diet consumption and dental caries, fluoride concentration and fluorosis. So what does this examples tell us? With an increase intake of carbohydrates, you have increase in the number of the dental caries teeth. With increase in the fluoride concentration in the water that you consume, there would be increase in the fluorosis situation. So this is the positive correlation. Now the negative correlation, as said before, negative correlation means you denote it with R is equal to -1. Now correlation is said to be negative when they move in opposite direction. In positive correlation, they were moving in the same direction, whereas in negative correlation, they are moving in the opposite direction. That means when one variable increases, then the other variable decreases. So let us see the examples here. Fluoride concentration and dental caries. So what is the negative correlation between the fluoride concentration and the dental caries? With an increase in the fluoride consumption, there would be decrease in the dental caries occurring in the teeth. So this is the negative correlation when they move in the opposite direction. The other example for the negative correlation would be the pressure and the volume of a gas. Now we have seen the positive and negative. The next thing we have is the zero correlation. So whenever you have a value of R to be 0, here the value of correlation coefficient means there is no association or a linear relationship existing between the two variables. That means when the two variables are compared, there exists no relationship or no linear relationship. For an example, number of accidents and number of marriages. Now how do the number of accidents relate with the number of marriages? So these are two variables which are not in association. There is no association existing between these two variables. That is the reason it is 0. Now the next thing is moderately positive correlation. So this can be any value ranging from 0 less than R to less than 1. That means the correlation coefficient is lying between 0 and +1. Then correlation between two variables is said to be moderately positive correlation. So moderately there exists a positive relationship between the two variables that are compared whenever you get a R value between 0 to +1. Similarly, when you say it is moderately negative correlation, that means the correlation coefficient here, it lies between -1 and 0. That is the value, it should be -1 less than R or less than 0. Then you can say it is moderately negative correlation, and the correlation between two variables is said to be moderately negative correlation. So this is about the different types of the correlation that exist and how they are interpreted. Now let us see the method of studying the correlation in the form of the graphical method. So graphical interpretation, how do? You do it with the help of a scatter diagrams. Now let us see each one with an example. The first diagram here, it is a perfect positive correlation between the college marks and the school marks that we have, the two variables. So they are in a perfect positive correlation, whereas the next one is a perfect negative correlation with the number of colds and the temperature. Okay, so number of cold occurring and the temperature is negative relationship. Then you have a moderately positive correlation for the tuberculosis and economic status that is present. And similarly, for a moderately positive correlation, we have age of the wife with that of the age of the husband, age of the sorry, this is moderately negative correlation, age of the wife and age of the husband. Next thing is this zero correlation. So you do not have any linear relationship, only in zero correlation you can see the scatter points. Now because we have studied the method of the correlation with the help of the scatter diagram, next would be method of studying correlation coefficient with the help of test. That is, the first one is the Carl Pearson's coefficient of correlation. So for the Carl Pearson's coefficient of the correlation, which is the denoted by R, you have this particular formula where the interpretation again R is +1, that is the positive perfect correlation, R -1 is perfect negative correlation. The next one is Spearman's rank correlation coefficient. It is used to study the degree of association between two variables by their ranks. Okay, so the rank correlation coefficient is given by this particular formula, which gives us the Spearman's rank correlation coefficient, where according to this formula, D means difference in the ranks, N means number of paired individuals, and this also lies between +1 and the -1. So this is about the correlation, that is the relationship or association between the two quantitative variables if it exists. So it can be positive, negative, zero, moderately positive and moderately negative correlation. The next one is regression. Regression is nothing but it is used for predicting or estimating the unknown value of one variable called the dependent variable from known value of the another variable known as the independent variable. So it tells us the dependency, or it predicts or estimates the unknown value of one variable from the known value of the another variable. So this is about the regression. So now that we are clear about the correlation, regression and the test of significance. So what we have seen in biostatistics, so the information or the data that has been collected, it has been tabulated, then you presented the data. After presentation of the data, we have seen the measures of central tendency and measures of dispersion. Then we have looked into the various normal distribution and normal curve characteristics, how it is and what it is. Then we have seen the test of significance based on the p-value. So under t-test we have seen paired and unpaired, and remaining test of significance. Now what questions can be expected from this particular topic? They can ask you to write short notes on the presentation of the data or the measures of central tendency, measures of dispersion, normal curve, tests of significance, probability sampling and non-probability sampling. So this is a very important topic for the short notes. So most of the short notes can be expected from this topic, that is biostatistics. So we have completed this topic. Thank you.